I'll preface by saying that I use analytics rather broadly to include statistics and data science, among others. Now, we think about using analytics to improve the quality of something else, but we don't talk much about the quality of the analytics itself. Do we want quality in what we do? Most people will say yes. Most people do not come to work wanting to do a bad job. But quality is also incredibly hard to articulate. You know it when you see it. But many attempts at analytical quality start with what quality notionally looks like, not with what quality actually is. And it goes without saying that we are responsible for the quality of our work. There is some precedent for formalizing the idea. For example, Eurostat has some papers on statistical quality. Their focus is on the quality of the statistical output, which is a part of the broader statistical practice. Also, they're specifically on official statistics, and the QA framework is largely institutional. So we want to consider analytical practices a little more generally. How do we define quality? The American Society for Quality says that it's either the characteristics of a product or a service that bear on its ability to satisfy stated or implied needs, or a product or service free of deficiencies. Either way, quality is about meeting some set of criteria or standards. The definitions by other established quality experts and organizations are quite similar. Now, this leads to the idea of defects. Whenever any of those criteria or standards are not met, you can consider that a defect. This gets us away from the subjective definition. So you can measure quality in terms of defects. Then the highest quality is the complete absence of defects. We can define a set of quality dimensions about how we do things, not just about what we produce. Appropriateness. Is everything appropriate for the question or the need? This includes the data, the sampling design, the analysis methods, etc. Defects here can cause biased or even irrelevant results, even if you did everything else perfectly. Clarity. Is everything free of ambiguities? This includes definitions, methods, specific steps, etc. Consistency. Is the analysis tool and system agnostic? Does it produce the same result every time you run the same thing? It is closely related to reproducibility. Traceability has to do with lineage. Do you know where everything came from and where everything went? Even extends to data lineage, which we're not always accountable for, but we are responsible for knowing how the data came to be. Accuracy here is different from the statistical definition and is the absence of executional errors. Transparency. Can you explain it, be it the analysis result or the analytic itself? Is everything clearly documented so that another person can understand from start to finish? Completeness. Is the logic complete with no gaps? Have you accounted for everything that matters? And finally, justifiability. Do you have a defensible reason for everything? What are the risks, dependencies, and limitations of your choices? We complain a lot about the quality of the data. There's an entire discipline on the topic with its own recognized dimensions of quality, and that's for another discussion. As statisticians, we hear a lot about replicability and reproducibility. From the statistical perspective, failure to reproduce or replicate should have defects in at least one of these dimensions. Since our profession does not exist without our clients, colleagues, and collaborators, the scope necessarily includes aspects of analytical project delivery, which are not all analytical. They generally fall into the following. Did you set clear expectations? Were they explicitly agreed to? Did you meet all of these expectations? Did you justify everything? Did you document everything? Are all outstanding issues resolved? And finally, does the client or collaborator agree that the expectations as stated were all met? Quality management is a life cycle, and although there are variations, it generally consists of the following components. Quality planning is where you define how you plan on building quality into your product. Quality assurance involves methodologies and standards you employ to build quality in as you execute. Quality control is ensuring you've done what you needed to do. Now, the distinction between quality assurance and control is often blurry. And finally, there is quality improvement. For our purpose, we can think of this as post-launch quality management. We won't go into the details of a project lifecycle, but in a typical analytical project, there is a discovery phase in which you initially find out about the needs. Then there's a design phase. Then you execute the analysis or develop the analytic. Then you hand off, operationalize, or deploy your results, and the results are used to make decisions. Your practice may not have these phases explicitly, but even a single consultation follows this conceptually. Discovery is typically pre-kickoff, so we'll put that aside for now and map the rest of the life cycle against the 4 components of quality management. The task of designing the analysis and the project so that we don't deliver defects by design is our quality planning. Quality assurance in our case is doing the project in a way that minimizes defects. That takes analytical and non-analytical methodologies and standards. Although we naturally think of the analysis execution here, it actually starts with design because how you carry out design activities can reduce defects. Our quality control may involve checklists, reviews, and audits to ensure you've done everything you're supposed to do throughout the project. Our post-launch quality is concerned primarily with monitoring the external validity of the analytic, as well as operational defects like system problems, changes in data structure, and shift in behaviors. The scope depends on the circumstances. I've implemented quality control as a system of independent reviews in various organizations. Having an independent team is often encouraged or even mandated, but that has pros and cons, and it may not be feasible for smaller organizations. Separating the delivery audit from the expert review has some practical advantages. Both are responsible for questioning what was done, but the delivery audit verifies against stated requirements, whereas the expert review is much like peer reviews in journal submissions, and each has specific objectives and assumptions. So here are some practical considerations for implementing a quality program from my own experience. First, inventory what you are managing the quality of. Roles and responsibilities. Who will do what? Who signs off on what aspects of the project? Processes and procedures. What does the workflow look like? You will also need some SOPs, or standard operating procedures. Standards and policies. What are the defects against? This includes checklists, forms, and standards, and it can get very detailed. Infrastructure, like a document store and shared environment. If you productionalize the analytics, you may need a test environment. Training on the expectations, methodologies, and techniques for quality. Some quality principles go against what many analytics professionals often consider elegant and valuable. Also, each person needs a delivery mindset. That is for another discussion. I look forward to your questions and comments.